So OSPF protocol always runs on cost.
Recording in progress.
Can you hear me?
Yes, sir.
Okay, awesome. All right. Yeah, sorry about that. Let's take a router. Connected to another router, right? Let's say this is R1, this is R2. Now, what OSPF does is, so let's assume that we have enabled OSPF between this R1 and R2, right? So if you have enabled OSPF, obviously you would have first gone into the configure terminal. You have given the command router OSPF, and you would have mentioned any process ID. And if it is 1.1.1.1 and this is 1.1.1.2, then you would have said network. First, I'm doing this on R1. Network 1.1.1.0, 0, 0, 0, 255, which is a wildcard mask. And you would have advertised this particular network. Same goes with this router also, but I would advertise same 1.0 network. Now, after this, I have another link. After this, I have another link and it goes via R3, right? And that is 2.2.2.1, 2.2.2.2. Let's say this is 3.3.3.1 and this is 3.3.3.2. Okay. Now, we have many things to see here. First of all, when you observe R2, R2 will say, now let's create a loop back on this R1, which is, let's say, eleven dot 11.11.11. In the routing table of R2. Let's write the routing table. Whenever you give a show IP route on R2, what all does it have? Simple. It has one dot network, which is connected directly on the interface. Let's say this interface is F0 bar 0. Then it has 3-dot network, which is connected via F0 bar 1. Also, it knows about 11-dot network, but if you advertise it. So let me go and advertise this one in the configuration command of R1, network 11.11.0.0.0.0.255. So it will be able to see 11.11.11.0, and this will be via this routing, that is 1.1.1.1 through the interface F0 bar 0, right? Through the interface F0 bar 0. But there is one more chance. I mean, there is one more way that it could learn. How? Via R3. Because R3 will also say, even I know about 11 dot network, right? And I will pass it on to you. One more way of learning 11 dot network is 3.3.3.1, right? This is the router which passes if they both are neighbors. Right now, here I haven't established the neighborship. I am assuming, I am telling you, please assume the neighborship is already there. They're exchanging routes now. All three are neighbors. 1 and 3 are neighbors. 3 and 2 are neighbors. 1 and 2 are neighbors. You want to exchange, the same 11 network comes to R2, right? It comes to R2 via R1 also and via R3 also. Now, which is the best route to select? As you know, our interior gateway protocols, they always have the best route in the routing table, right? They always have the best route. In the topology table, all the possible routes are present. In OSPF, we do not have topology table. Instead, we call it as a database table, right? In the database table, we have all the possible routes. But in the routing table, we have only best possible route. So we have to select 11 dot network among the first and second 11 dot network received, because this is the same network, right? We have to choose either one, which is the best. For this purpose, OSPF uses the cost factor, right? So what is the cost? Cost is the unit of OSPF through which it decides which route is the best route, right? Hope you are clear on that. No questions on that, right?
Yes, Ram.
Okay, moving on. I think I have allowed everyone to speak. Yeah, okay, right. Okay, moving on. Excuse me. how does this cost look? Right? How does this cost look, or how do you decide the cost? Harpreet, any questions?
Yes. I'm same question like how they like select the cost, like how they find the best route.
Yeah, sure. I'll let you know. Okay. I just was speaking about the same. I'll let you know. Okay. How it will select the cost, how it will decide which one is the better. Now we'll take the same diagram again. Okay. Two scenarios. Let's say this is three routers, right? R1, R2, R3. The same R1 and R2, R3, right? They are connected with the same. No changes. 1.1.1.1, 1.1.1.2. This is 2.2.2.1, and this is 2.2.2.2, 3.3.3.1, and this is 3.3.3.2. And we have a loop back here, which is 11.11.11.11, right? Now, consider fast Ethernet interfaces. For example, F0 bar 0, F0 bar 1. This is F0 bar 1, and this is F0 bar 0. This is F0 bar 1, and this is F0 bar 0. 0. Yeah. Now, when it comes to fast Ethernet interfaces, there is some standard, right? There is some standard. Now, what is the standard? Standard is for all the interfaces, which is fast Ethernet, right? The cost will be 1, or cost is equal to 1 of any fast Ethernet interfaces. Why? Cost is equal to, the formula to calculate the cost is 10 power 8 divided by bandwidth. Cost is equal to, now what is cost? 100 Mbps. 100 followed by, this is 100, this is kbps, this is mbps, right? Divided by 10 power 8 is this one. 1 followed by 8 zeros. Then the bandwidth of fast Ethernet interface is 100 Mbps. We all know that. We all discussed that. The bandwidth of Ethernet, just Ethernet port, is equal to 10 Mbps. We know that. The bandwidth of gigabit is or gig port is 1 gig, right? We all know that. Now, according to the formula, the bandwidth is 100 Mbps, so it should be 100 followed by 6 zeros, which is equal to 1. So, any fast Ethernet interface, this is a fast Ethernet link, right? The cost of this link is 1. The cost of this link is 1. The cost of this link is 1. So whenever you see the routing table of R2 in the previous example, right? To reach 11 dot network, this is 11 dot network via 1111 from this router, this way, the cost will be only 1. But to reach via 3331, you calculate the cost. It has to go here, which is cost 1, because this is a fast Ethernet link. And from here to here, cost is 1. So 1 plus 1 is 2, which is cost is 2 here. So which route would the OSPF prefer? The first one, right? It will always prefer the first one. So whenever you do a show IP route command on R2, you can see only this particular route. Why? Because it has a lesser cost. It has a lesser cost, better cost, right? It is cost effective. But where can you find the other route? Where can you find the other route? It can be found in the database table of OSPF. It can be found in the OSPF database table. How to check that? You already know. Show IP OSPF database. In that, you will see all the possible routes to reach 11 dot network. Right? That is about the cost that we had. Do you have any confusions?
No, no.
Okay, awesome. All right. So let's move on. Moving on. We speak about DR and VDR selection. No. Okay. No, I think we did not speak on that. Let's take. Now, the next topic would be OSPF, DR, and VDR. Now, what is DR and VDR in OSPF? DR is nothing but your designated router. What is VDR? VDR is backup designated router, right? Backup designated router. Now let's consider a switch connected to 3 routers. Right? 3 routers. 192.168.1.1, 192.168.1.2, 192.168.1.3. Now, why all 3 are in the same network? Because they are connected to the switch, right? Any interface, all the interface of the switch are in the same network. They will be in the same subnet, right? Now, there are 3 routers, right? There are 3 routers. What I have to do? If I have to become neighbors, now let's say all of them have a loop back. This is 22.22.22.22.22. This is 33.33.33.33 on the loop back. This is 11.11.11.11. Okay. All of them have a loopback address. If R1 has to get to know what is on the R2 loopback, first of all, if this router has to get to know, this router has to get to know what networks does this router have, then it has to establish neighborship with that particular router. Okay, fine. Let's establish OSPF neighborship then. Okay, that's even better. I'll go to the configuration terminal here. I will say configure terminal router OSPF 1, and I'll advertise this interface saying network 192.168.1.1. Then I will advertise. Any neighbor of mine can also see network 11.11.11.11/32. I advertise both the networks and I enable OSPF feature on this router. Right? I enabled OSPF on this router. Now it's enabled. But to form neighborship, the command only on one router is not sufficient. The command should be on both the routers. Right? I'll go to this router. I'll say router. Good morning. Hi. Router OSPF 1. I'll say network 192.168.1.2. Wildcard mask is 255. So the moment you give this command, network 192.168.1.2 and enter the wildcard mask, this neighbor will be established. Neighborship will be established, and the reason why is whenever you give the network command on this particular subnet, a hello packet will travel to this particular router. Why this particular router? Because the hello packet will be traveling to the multicast address 224.0.0.5. And by default, all the OSPF configured routers, excuse me, guys, give me one minute. Okay. All the OSPF configured routers. How do you say they are OSPF configured? By this particular command. Any router configured with this command, router OSPF1, is known as OSPF configured router. This particular router will be able to hear all the messages on this address. So the hello message that is sent by R1 to this address will be heard by this router. Now, when it hears the hello message, it can only reply when I give a network command, right? When I give a network command on this particular subnet also sends a hello message, and this time it would be directly to R1, right? So they become OSPF neighbors. Once they are neighbors, we will be able to advertise whatever the networks we need, right? Now, I will say not only your neighbors, but you're exchanging the loopbacks also. So on the R1 side, you will give a network command on 11.11.11.11 0000 as the wildcard mask. Here on the R2 end, you will say network 22.22.22.22. And the wildcard mask becomes 0, all zeros, because it is a /32. Now, by doing this way, we will be able to exchange the loopback networks of R1 and R2 with each other, right? Now, when they have, oh, I'm so sorry about that. When they have exchanged each other loopbacks and you do a show IP route on R1 you will be able to see, I am able to see 192.168.1.2, who is my neighbor, and I am able to see his 22.22.22.22 network because he has given a network command on it, right? And also, if you do the same thing on R3, you will see R3's 33.33.33.33 network also, right? You will also able to see that network in the routing table of which one? R1. So basically, the thing that we're doing is we are trying to make all the routers know about, aware about each other's connected networks, each other connected networks. We are making them aware of the networks that are connected to each other routers. Awesome. Okay. But what is the concept of DR and BDR here? it starts with this, right? Trust me, it starts with this. Now let's move on. Yeah, Harpreet, go ahead, Harpreet.
Where is like backup and designated?
I'll tell you. I'll tell you. So
And one more thing, I have a little doubt. I think we can't give the /32 subnet mask because it is used for broadcast uh, for for a broadcast.
no, 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 not at all. Not at all. Not at all. That is not the correct concept that you that is not the correct understanding. /32 mask can always be given to any IP address. If you want this particular interface to have an IP address of 192.168.1.2 only, or if you wanted to have 22.22.22.22 only, then you can give a /32 subnet mask. That is 255.255.255.255. So you are actually confusing with this is the IP address of loopback 0.
Yes.
You don't confuse with the subnet mask column. Now, what is the broadcast address? Broadcast address is 255.255.255.255. Where? Not in the subnet mask.
Okay.
It's here, right?
Okay. So there that means we can give subnet mask like this one also.
Exactly. So the subnet mask can always be anything,
Okay.
right? It can vary from this octet right here. It can vary from here, 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 anywhere, right?
Okay.
Subnet mask can vary. Don't
Okay.
confuse between this column because this is the IP address that you're giving. If there is all 255 here, then that is the broadcast address.
Okay.
But your all 255s are here in the subnet mask column.
Yes.
Okay. Now, moving on to the concept of DR and BDR, we have routers and switches. You saw in the last diagram that I had written R1, R2, R3. If so, let's say this is 33, this is 22 connected, this is 11 connected. Now, if R1, I'll ask you a simple question, try to answer if it is possible. If R1 has to come to know about R3 network, that is loopback network 33, what is the steps that we're going to take? Or any solution you guys have?
Yes. First we configure a routing protocol.
Exactly, which is
Yes.
very correct.
Then it is send a request through a multicast IP
Very good.
because it doesn't know the designation router.
Mhm.
So it will send a hello message
Correct.
through a multicast IP. Then after it will designated IP send back acknowledgement message to the source router.
Right. First, we establish neighborship with R3, right? If we want to know about 33 network connected behind R3, first we establish neighborship. How do we establish neighborship? We configure OSPF on both of them. So they start sending hello packets. Once the hello goes, the neighboring router will now respond with a hello and it will update its routing table. This one will say thank you, acknowledged, and this one will also say update, that is its routing table. Then it will say acknowledged. This is the process usually, right? And we have also discussed a 5-step process, how this acknowledgement and all this happens. 5-step process, which is down, init, two-way, start, exchange, and full, right? In the previous video, we can check that. So neighborship is established. After the neighborship is established, we have to just give a network command on this router in OSPF column. We have to just say network 33.33.33.33. Then that particular network will be advertised here. Here we have to say network 11.11.11.11. Then 11 network will be advertised, right? Then these both can see each other's network. Okay, fine. That is the way to see any network on R3. Fine. What about R2? Same process. Establish neighborship with him and give a network command on this one and this one. So he'll be able to see yours and you will be able to see him. Okay, fine. There is another router connected, R2. 44 network is here. If you want to see that, same thing. Establish neighborship here. Give a network command on your network. Give a network command on his 44 network. Then you will be able to see. He'll be able to see. R5 is there with a 55 loopback. Same thing. Establish whatever neighborship network command that works. R6 is there. 66 network. Again, neighborship network command. If you establish neighborship with R1, R1 will be able to see 66 network. What about R4? Same thing, you have to establish network with OSPF neighborship with R4 as well. So what are you seeing here, by the way? You are seeing multiple neighborships established. Mostly all of the routers are establishing neighborship with all the other routers. Isn't it a too many messages in the router? Isn't this a too many neighborships established, right? There are lot of neighborship messages, lot of neighborships established. R1 has to know about R2 network. Established neighborship here. R1 has to know about R3. Established neighborship here. About R4. Established neighborship here. They have to know about each other, established between them. Right? It's a lot of neighborship in OSPF. Right? Means if you can see it in layman terms, any person, 4 people, have to know about their status, which place are they living. He has to call him. He has to call him. He has to call him also. He has to call him also. He has to call him also. Right? At the same time, person 2, right? He has to call him, him to get to know which place they are living. They have to call each other. But wouldn't it be nice if there is any other scenario? Like how? There is a person here There are many people here. Wouldn't it be nice that there is some dedicated person, designated person? Everybody update him which place they are staying. And he in turns updates about this guy, he updates to him, him. About this guy, he updates him, him. Right? This would be little easier. And why would I say it is easy? Why would I even say it is easy? Because you have to establish neighborship only with him and update yours. And if you see the diagram, he is actually connected with all of them. Once you update yours, since he is called connected with all of them, he'll send the update to others. Isn't this easy? Because if you want connection between these two, you had in the previous traditional method, you had to create between these two also, right? These two also. But here it is not happening. Apart from the designated person, you are not updating anybody else. This guy who is the designated person, it is known as a designated router. And we always, for the redundancy sake, we always keep a backup one, which is known as backup designated router, right? We have a backup designated router. Why? What is the reason for the redundancy? What if this router goes down? Because he is handling all the information. What should happen to the information if he goes down? They are in sync with backup designated router. He maintains all the database, right? This is the concept of designated router and backup designated router. This is the concept. Now we saw it in the person wise. Now let's see in the router wise. Let's have a router here. The same scenario, nothing different. Okay. We have a router here. We have a router here, here, here. Right? Now, let's assume R1 is the designated router. I'll tell you how it is selected and all that. I'll first tell you R1 is the designated router. R6 will come, form only neighborship with R1. But before, you knew that if it had to learn about 11 network, which is connected to R1, you will obviously form relationship, fine. But if you had to know about 44 network, this R6 had to also form neighborship with R4, but now it is not. It is only forming neighborship with R1. R4 comes, he forms neighborship only with R1. This guy forms neighborship only with R1. Same goes with R3, only neighborship with R1. Same goes with R5, only neighborship with R1. R1 knows about everybody routes now. It knows about the 55 network here, 33 network here. When I say 33 and 55, what I mean is 33.33.33.33/32. This is what I mean. Okay. Do not get confused. Just for avoiding some writings, I have written it like that. Similarly, here 22.22.22.22. Okay. Same goes here 44.44.44.44. Right? R1 will know about everybody's network. 11, 22, 33, 44, 55. Now what it does, if you have seen R1 is connected to R6 also, R4 also, R5 also, right? Through this one, this one, this one, this one, and this one. Now it has learned 22 from here. So it won't send 22 back here, right? What it will do, it will send the rest of the networks. Send the rest of the networks, which is 33, 44, 55, 66, and 11. It will send the rest of the networks to R2. To R6, it has learned 66 from here. Apart from 66, it will send all the networks to R6. Why? Now, there is a rule. What is the rule? The interface on which you have received anything will not be sent back to the same interface. You know that, right? In the routing, switching, and all, you were aware of that. So 66, which is coming from here, will not be again going back to the same R6, right? Instead of 66, everything else will go here. Now, what it becomes R1? It is a designated router. Designated router. Now, why did they make this concept of designated router? Because initially they had one or two routers like this in the company. One router, two router, three router. But as the network began, as the internet started evolving, there were companies with 500 routers, 200 routers. It was a very big task of establishing neighborship with all the 200 routers. Fine, 200 is fine. What about the scalability? When I say scalability, what does it mean? After 200 routers, you thought of adding one more extra router, the 201 router. That 201 router has to form neighborship with the other 200 which are there. The other 200 has to form neighborship with this 201th router, right? If you add just one, see how many neighbors you have to establish. But here, by using designated router, even if you had a 201 router, 201th router, you just have to establish neighborship only with that designated guy, designated router. It will not be a burden on any other routers. As simple as that. That is why there came a concept called designated router and backup designated router. Now, since you know the concept a bit of designated router, Let me explain a little more deep on that. What is little more deep? R1 is a designated router. Now, you have a company. Imagine you are owning a company. You have four routers, R1, R2, R3, R4. You want to make one of them as a designated router. Obviously, which one will you make? Simple. This is a high-end router which can handle more traffic. Then do this as a designated router. You may not, so it will actually save your expenses. How? I can take this as a low end router or a medium range router, this as a medium range router, this as a medium range router, but this is a high end router. Why high end router? Because it has to handle all the traffic and also have to give back information to many others, right? That is why I'm choosing this one as a designated router. Now, how to change how to decide this is the designated router? Simple, very simple. This is the one which is connected, right? Interface fast Ethernet 0 bar 0. Go to interface fast Ethernet 0 bar 0. Simply say IP OSPF priority and give the number that you like. By default, the priority of all the interfaces will be 100. By default, all the interfaces will be having the default priority of 100. If you give something more than 100, which is 200, then that particular router will be chosen as the designated router, right? That will be chosen as a designated router. Now, you have changed the priority of this one to 100. How will other routers know? Is this a concept where we are doing neighborship with everyone, or is this a concept of DR and BDR? How does it know? Because there are two networks. One is a point-to-point network, means one device connected to one device only. Point-to-point network. One device connected to two devices, more than one device. This is a broadcast network. Now, when I say router OSPF 1, R2 will know, okay, maybe is one of my neighbor. But if I say router OSPF 1 and the hello packet goes to R2 also, because R2 is also configured with OSPF, as you remember, router OSPF 1, same process ID. It will come to know, okay, this is a broadcast network. And in broadcast network, broadcast multi-access network. What is a multi-access network? Where more than one devices are there. If it is a broadcast multi-access network, then I have to choose DR and BDR. So whenever router sends hello packet, right? First, it will send its subnet. What subnet I am coming from? Let's say 1.1.1.1. Then it will mention what is its area. Let's suppose R1 is sending a hello packet. What all this hello packet has? What is the area of R1? Now it will say, what is the hello interval? Means how often I will send hello packets. What is the dead interval? After how long I'll consider my neighbor is dead? Sorry, it should be 10 and 40. After 40 seconds, I'll consider my neighbor is dead. Along with that, it will say, what is my priority? Right? These are the things it will carry in its hello packet. Router 2 will see, hey, this guy has area. Okay, he's in my same area, 0. So we can do neighborship with him. And he is 1.1.1.1. I am 1.1.1.2. So he is in the same subnet. So I can do neighborship with him. Hello, 10 seconds. Okay. This is set as same thing on my end. Otherwise, if my hello is 20 seconds and dead interval is 80 seconds, what I'll do, I will agree on the shortest one, right? On the shortest one. Then I'll see the priority. Hey, this guy has a priority more than me. So in the election of DR and VDR, at the same time, I will configure OSPF, router OSPF on this one. Hello packet will come here also. This guy will say my priority is 100. I will say router OSPF on this also, and I'll advertise the network, whatever. This guy will also send hello packets. It will not send individually to 3 routers. It will just send to 224.0.0.5. Automatically, these 3 routers are listening to this. They'll get to know only router one's priority is 200. Ours is just 100. So we have to listen to him. Automatically, it will decide router 1 is the designated router. Backup, do we have to do anything on the backup? No, do not do. Give the second priority 150 to any router. That will be chosen as the backup designated router. Simple as that. Okay, nothing extra. Give the second highest priority to any other router, it will become backup designated router. As simple as that. Okay. Now, this is called a DR. The second one, with second priority, is known as BDR. Then what are this known as? These are known as DR other. Means they are not designated router, they are designated other designated routers. Right? And one more thing I have to correct, the default priority is it's 1 and not 100. I told you 100, it is 1. Default priority. By default, any router will have a priority of 1. Now, you will introduce another router, R100, and you don't want this to be DR or BDR or anything. What to do? I don't want it to participate in the election at all. Do one thing, go to this interface, F0 bar 0, and give IP OSPF priority as 0. If you give IP OSPF priority of any interface to be 0, it will never take part in any election. It will never become DR or BD. Right? Any confusions on this one?
No,
Are
sir.
we, are we good?
Yes.
Awesome. Okay. So I can say that is quite good. So we have BGP as the next concept. Do you want me to continue with BGP? The next protocol that we have is BGP. Do you want me to
Okay.
continue?
I think we want. Eh, if you show me the like practical of the DR BDR, is it
Sure,
fine?
definitely. So our next class would be the lab, right? So this is just a theory class. So the next class would be the lab. I'll show you both EIGRP, OSPF adjacency, everything, and the DR-BDR relationship through a lab routers. Okay?
Yes. Yes, sir.
Okay. So the next protocol, what I was thinking is I will, you know, introduce the BGP as well. And since we are going into the lab, I will execute all the three protocols together. That is EIGRP, OSPF, and BGP together, so that if you configure three protocols on the routers together, back to back on the same day, I thought you will be able to make out the differences between these three. That's why I planned, like, you know, having the lab of all the three protocols together on one day. Would you
Yes. Yes.
would
Yes.
that
Yes.
okay? Okay. All right. So next concept is BGP. Would you want to deal with it today, or are you confused? Do you want me to give you some time?
Rahul, in OSPF, we have a stub area right, like that, right?
Exactly. Exactly.
Actually, I want to know about that also in OSPF.
Definitely. So it is not in your syllabus, but if you want to know about stub area, definitely I'll teach you that. Don't worry at all. So if you
Okay,
if
okay.
you are if you are willing to learn and it does not confuse you, because I don't want to
Actually,
put.
interviewer has asked me a question regarding stub area, but I didn't explain because I have no knowledge about stub area. That's why I said,
Definitely. So what we can do is, so this is not a part of CCNA syllabus. I mean, your
okay,
exams. So that is why I'm not confusing people, because I don't want to, more confuse them and make them forget the concept. So I did not take that topic. But if you want to learn, I'll definitely teach you separately, or whoever wants
okay,
to
okay,
learn, we can run it on separately.
okay, okay, Rahul, no problem.
All right, so it's your wish, guys. So if you want me to continue with BGP today, I can continue. If you want me to give you a gap, I can give you a gap. However, you are comfortable.
Give me a gap for today so that we can revise all the OSPF.
Okay, so not a problem. So, but I would request you guys please go through the recordings so
Yeah,
that we'll be having a clear, a matured mind tomorrow, so that we can understand as and when I'm explaining. Okay,
Sure,
yeah,
Rahul.
then
definitely.
let's all meet tomorrow, guys. Have a great Saturday. Take care.
Thank you, Rahul. Same to you.
Bye.